Mercury, a tiny world in the sun's embrace. Mercury is a planet of extremes. It is the smallest planet in our solar system, a mere speck of rock and metal compared to giants like Jupiter or Saturn. Despite its size, Mercury holds a significant place in the cosmic dance of our solar system. This tiny world is also the closest to the Sun, whizzing around our star at an average distance of 36 million miles. Its orbit is highly elliptical, causing it to speed up and slow down as it travels around the Sun. Imagine the scorching heat and blinding light that bathes Mercury's surface. The Sun appears more than 3 times larger in Mercury's sky than it does from Earth, and the sunlight is up to 7 times more intense. Despite its proximity to the Sun, Mercury is not the hottest planet. That title belongs to Venus thanks to its dense atmosphere. Venus's thick clouds trap heat in a runaway greenhouse effect, making it even hotter than Mercury. However, Mercury experiences the most dramatic temperature swings of any planet in our solar system. The lack of a substantial atmosphere means that there is nothing to retain the heat once the sun sets. Temperatures can soar to a blistering 800 degrees Fahrenheit or 430 degrees Celsius during the day. This intense heat is enough to melt lead, but at night, without a substantial atmosphere to trap heat, the surface plunges to a frigid minus 290 degrees Fahrenheit or minus 180 degrees Celsius. This makes Mercury a world of stark contrasts. Mercury has intrigued astronomers for centuries. Its close proximity to the Sun makes it challenging to observe from Earth, but its unique characteristics make it a captivating subject of study. Early astronomers could only catch fleeting glimpses of Mercury during twilight hours. By understanding Mercury, we can gain valuable insights into the formation and evolution of our solar system and planetary systems around other stars. Studying Mercury helps us understand the processes that shape rocky planets. So, let's embark on a journey to this enigmatic world where we'll explore its scorching surface, its hidden depths, and the mysteries it holds. From its ancient craters to its mysterious magnetic field, Mercury has many secrets waiting to be uncovered. Mercury races around the Sun faster than any other planet, completing one orbit in just 88 Earth days. This incredible speed is a result of its close proximity to the Sun, which exerts a powerful gravitational pull on the tiny planet. This swiftness is due to its proximity to the Sun and the Sun's strong gravitational pull. The closer a planet is to the Sun, the stronger the gravitational force it experiences, pulling it along its orbit at a breakneck pace. Imagine being on Mercury, where a year whizzes by in less than 3 Earth months. This means that if you were to celebrate New Year's on Mercury, you'd be doing it 4 times in a single Earth year. But here's where things get even more interesting. Mercury's rotation is quite peculiar. Unlike its rapid orbit, Mercury rotates on its axis very slowly, creating a stark contrast between its orbital and rotational periods. While it orbits the Sun quickly, it rotates on its axis very slowly. This slow rotation means that Mercury has one of the longest days of any planet in the solar system. In fact, it takes Mercury 59 Earth days to complete one rotation. This slow spin results in a day on Mercury being significantly longer than its year. This means that a single day on Mercury, from sunrise to sunrise, lasts for 176 Earth days. Imagine experiencing a sunrise that takes nearly 6 Earth months to complete. This unusual relationship between Mercury's orbit and rotation creates some bizarre effects. The interplay between its rapid orbit and slow rotation leads to unique phenomena that are unlike anything we experience on Earth. If you were standing on certain parts of Mercury's surface, you would see the sun rise, then gradually set again as the planet's slow rotation brings it back towards the night side. This would be a surreal experience, watching the sun dance across the sky in such an unusual manner. But then, as Mercury continues along its orbital path, the sun would appear to reverse course and rise again before finally setting for the day. This back and forth motion of the sun is a direct result of Mercury's unique rotational and orbital dynamics. Mercury's eccentric orbit and slow rotation are just two examples of the fascinating and sometimes counterintuitive phenomena we encounter when we study the universe. These characteristics make Mercury a particularly intriguing subject for astronomers and space enthusiasts alike, offering a glimpse into the diverse and wondrous mechanics of our solar system. Peering through telescopes, astronomers saw a world that looked remarkably like our own moon, a desolate landscape scarred by countless craters. These craters are the result of billions of years of impacts from asteroids, comets, and other celestial debris. Some of Mercury's craters are truly colossal. The Caloris Basin, for example, stretches across a staggering 960 miles, or 1,550 kilometers. That's roughly the distance between New York City and Miami. The impact that created the Caloris Basin was so powerful that it sent shock waves rippling through the planet, creating strange, jumbled terrain on the opposite side of Mercury. But Mercury's surface isn't just a monotonous expanse of craters. There are also vast plains, towering cliffs, and long, winding ridges. These features suggest a more dynamic geological past than scientists initially imagined, with volcanic eruptions and tectonic activity shaping the planet's surface. Imagine a world where the sun blazes with unimaginable intensity, turning the rocky surface to molten glass. The heat is so fierce that it transforms the very ground beneath your feet into a shimmering, molten sea. This is the daytime reality on Mercury, the closest planet to our star. Orbiting the sun at an average distance of just 36 million miles, Mercury endures some of the harshest conditions in our solar system. With temperatures soaring to 800 degrees Fahrenheit, lead would melt underfoot, and any atmosphere to speak of would be boiled away into space. The searing heat is relentless, making the surface an inhospitable wasteland. Yet, Mercury clings to a tenuous shroud of gases, an exosphere so thin that it's closer to a vacuum than any atmosphere we know. This exosphere is composed of atoms like hydrogen, helium, and oxygen, which are constantly being stripped away and replenished. This wispy envelope, constantly replenished by solar wind particles and atoms blasted off the surface, offers no protection from the sun's relentless radiation or the vast swings in temperature. The solar wind, a stream of charged particles from the sun, bombards Mercury, adding to the planet's extreme environment. As night falls on Mercury and the sun's fiery gaze is averted, the surface plunges to a frigid minus 290 degrees Fahrenheit. The lack of a substantial atmosphere means that heat escapes rapidly, leading to these drastic temperature drops. This dramatic temperature swing, the most extreme in our solar system, highlights the planet's stark and unforgiving nature. The contrast between day and night is a testament to the harsh conditions that define Mercury. The study of Mercury's exosphere, though seemingly insignificant, provides valuable clues about the processes that govern planetary atmospheres and their interactions with the solar wind. By understanding these interactions, scientists can gain insights into the behavior of other celestial bodies and the evolution of our own planet's atmosphere. It's a reminder that even in the most harsh environments, there are still stories to be told and mysteries to unravel. The exploration of Mercury continues to challenge our understanding and push the boundaries of what we know about the universe.